All right. All right. Okay. It's already 9:01 and thanks for joining today's webinar. And I'm Yingjun. Today I'll be talking about for the laptop Lakehouse. Work with Apache Iceberg locally. With no Dockers, with no Spark, with no complex setup. So if you know RisingWave, we probably, yeah, if you attended our webinar before, you probably heard that, well, okay, we actually talk a lot about, okay, how to optimize Iceberg, right? Well, how to pick the query engines, how to pick the catalogs, and probably how to do ingestions, compactions, whatever. But essentially what I found here over the last almost 2 years was that okay, if feel that okay, it's really hard to start with iceberg, right? They feel that okay, it's not just a starting with iceberg, but also yeah, how to tune iceberg, how to optimize iceberg, and how to just easily build with iceberg. So yeah, that's definitely pain, right? Well, and I don't really think that well, Iceberg should be just designed for the big companies with a very, I mean, large engineering team, right? Well, I mean, we think that's definitely everyone should well have the yeah can directly use Iceberg in their own way, right? Well, especially even if they want to just use well laptop in their I mean query Iceberg or write data into Iceberg using yeah, using their laptop, right? So that's what motivates me to talk about the laptop lakehouse, how we can work with Apache Iceberg locally in your own laptop. Well, I'm Yingjun Wu, and I'm a founder of RisingWave Labs. Okay, for every single webinar, I do a self-intro, right? Well, basically, I did a lot of works over the last 10 plus years regarding database systems, stream processing, and many other topics. And these days, well, definitely, I also work on a lot on AI infra. Well, I mean, because well, I do believe that well, probably for the next billion users, it could potentially it could be not for like humans, right? Well, for the next billion users of the data infra systems, it could be like just agent, right? So that's why we actually also spend a lot of time working on the AI and the agent infra. And essentially, for today, I actually do have a guest. I do actually do have a guest speaker. That is Cloud Code. Well, the reason here is that well, I feel that well, typically we do live demos, right? And I feel that well, actually, Cloud Code is probably the best way to do live demos because well, I personally do not need to type in any code, right? And here I just let okay, can you say hello to everyone? Okay, and let's just have a Cloud Code to self intro, okay? Um. So okay, he says that well, he is happy to be here, and just build a great something great with RisingWave and Iceberg. So as you can see, we have already granted a Cloud Code a Superbase Postgres connection and a RisingWave instance running locally, and definitely my AWS credential. I mean, I assume that's where, yeah. I assume that's where you have everyone has the AWS credential. But well, I mean, if you think that, well, okay, you are not using AWS, then you can definitely switch to, let's say, GCP or Azure or some other cloud. Or even probably you can choose Bing.io or some other alternatives. But for today's meetup or definitely a webinars, well, definitely I would assume that, okay, we just use AWS, right? So that's why I need to have a AWS credential. And for this one, oh yeah, we can just rebuild everything. Well, for Superbase, well, I mean, it's just like a random PostgreSQL instance I created. So yeah, let's see how we can use that. Okay, yeah, let's get back to your webinar. Yeah, my slide deck. So what a writing wave is? Well, I mean, just 1 minute, well, actually even 30 seconds. Writing wave is the enterprise grade well event streaming platform and it's specially designed for real-time ingestion, stream processing, and nowadays for Iceberg analytics. So we actually started RisingWave around 5 years ago, and at that time, RisingWave was pretty much focused on stream processing, right? And we believe that okay, at that time, I mean, if you think about the stream processing, the only systems you can use is probably Spark Streaming, Flink, right, or probably KCODB. But we feel that well, that was yeah, kind of like too complicated to use, right? When you probably have to understand about how to use their Java API or Java SDK, or probably have a very yeah, even though they provide a SQL, you probably also need to understand how to program in their dialect, right? SQL dialect, because right, it's not like a standard dialect. So we started RisingWave 5 years ago, and at that time we just think about okay, let's just allow people to enable people to use stream processing, use PostgreSQL, right? And we started and we built an entire system from scratch. We're not built on top of Postgres, but we built on top of we built a system from scratch in Rust. And today we have already expanded our scope to real-time ingestion and as well as Iceberg analytics. So it's basically an end-to-end data platform now. So regarding use case, well, if you think about what the data streaming, definitely, yeah, people are thinking about okay, monitoring, alerting, right? And these days, well, I feel that well, a lot of people actually use RisingWave for IoT telemetry, probably IoT devices, right? Well, or probably telemetries, or probably they want to do something like log and analytics, right? Well, all these kind of like and all probably user segmentation, marketing, right? Well, so for all these kind of things, well, as long as well, you need to do something, you need to deal with streaming data, yeah, RisingWave could be a very good fit for you. Um, And so for Iceberg, people ask us a lot about okay, why we started when we started working on Iceberg. We actually had started working on Iceberg since well December, September 2022. So in some of our meetups, well, I actually told people that we actually started working on Iceberg yeah, accidentally. The reason here is that for the at that time we were thinking about okay, we actually want to have a I mean RisingWave itself like it's a raw use it store data in raw format, right? But we feel that okay, yeah, people actually want to do analytics, and we definitely want to have a column store, right? And if you think about the column stores, well, then any options you or what options you have. Yeah, definitely people are thinking about Bakway because, well, I mean, because we believe in open source, right? Well, and we definitely believe in open format, and definitely we're thinking about Bakway. And but if you just maintain like say your data in Parquet format, then the challenge here is that you actually have to manage the catalog, right? Because well, I mean you cannot just put all the data into one single Parquet file. You probably end up with like say in for one table you probably end up with let's say 100 Parquet files or probably 1,000 Parquet files, right? If you have so many Parquet files, then you definitely want to manage, okay, the metadata, right? Because well, you need to understand, well, okay, which metadata I want to, which Parquet file I really want to access to, right? So that's why we actually look at into different table format. And Iceberg is definitely I have to say that's why it's probably the was most suitable data format for us or table format for us. And that's why we started working on Iceberg since well actually actually more than 3 years ago. And over the last 3 years, we have already seen that well, Iceberg community has already, I mean, it has already become the default data table format, right? And we actually also contribute a lot to the Iceberg community. For example, when we started working on Iceberg, I mean, there was just like a Java API, Java SDK. But today we actually had an Iceberg Rust project, right? Which was actually initiated by RisingWave guys and some other companies. And today we also support it. We have already become the very few companies very few products that's possible. I mean, all kinds of the catalogs and all kinds of advanced features like exactly once, all kinds of the compaction strategies, and also V3. We will probably release the deletion vector support for in probably in a month. Yeah. Okay. And for RisingWave, what Rising can do with Iceberg? As I mentioned, well, I mean, we are like we are probably a very one of the very few engines that can have a full integration with Iceberg, which means that we can actually read the data from Iceberg, and we can also sync the data into Iceberg. And in the meanwhile, yeah, one of the challenge of Iceberg is that well, it always have a lot of small files if you write the data directly into Iceberg. So for RisingWave, we can also do the auto compaction for you, meaning that okay, you do not really need to care about okay how much data you write into Iceberg. You just write into Iceberg well in using RisingWave protocol, and the RisingWave can handle the compaction for you directly. So regarding how to build an iceberg, right? Well, and regarding okay, how to build an iceberg lakehouse, right? Because well, we always talk about well, lakehouse, right? For lakehouse, well, the essence of lakehouse is that we can store the data in the open data format. And in that way, you could actually have your use all kinds of the query engines to query the data. Um, uh, uh, you query the data using whatever engine you want to use, right? For example, yeah, people probably want to use, well, let's say DuckDB, or probably use or want to use, let's say Snowflake, or probably yeah, Trino, ClickHouse, whatever, right? And we definitely feel that's where this is a trend. For example, in Redshift, I used to work in Redshift, and Redshift nowadays will actually have the Iceberg as their default query storage engine. So, so essentially, people really want to have all the data in one data format. So that's where, yeah, so that's where you can avoid the vendor lock-in, and you can actually store the data very cheap, right? Well, cheaply, right? Because well, everything is stored in S3, and you can even use well, the S3 tier storage to further cut the cost if your data volume is huge. But what's the simplest way to start building an open lakehouse? Well, we all understand the benefits of the lakehouse, right? But the challenge here I find is that if you want to start working with Iceberg, well then you actually have to learn how to use Spark, how to use Flink, how to use probably Kafka, how to use well whatever yeah all kinds of like big data systems, right? Why that's the case? The reason here was that well yeah because well the iceberg was like yeah you can kind of like think of the iceberg as a better hive, right? And because of the all kinds of the yeah historical reasons well yeah for the integration part well I mean definitely for Spark yeah it's definitely not a legacy system, but for Java-based systems, well, they definitely have a better support. They used to have a better support for Iceberg. But we feel that's okay if I mean, for modern systems, right? Well, for modern companies, well, a lot of companies directly use fully managed services, or they directly use, well, let's say Rust-based system or C++-based systems, right? They no longer use Spark, or probably they no longer use any Java-based systems. That's probably one of the trends you may observe. So we feel that's what I mean. If you yeah, it's probably not the right time think about well to educate people how to use Spark in order to yeah interact with Iceberg, right? And if you look at well, all the different well let's say query and if you look at well, all the different tutorials, right? And here I have a yeah let's just search for let's say Iceberg's tutorial. Apache Iceberg tutorial. You will find that, well, yeah, definitely there are some ads, but well, you will find that well, people always ask you to download well Spark and always ask you to probably create a Docker image, right? Well, probably use Docker Compose. And yeah, I don't know what it is, but well, yeah, you can see that what it's very complicated and it's definitely not very user friendly because well I personally don't really have create a let's say a Docker image right well I'll bootstrap my Docker in order to complete some let's say yeah some simple use cases, right? So it's very complicated and I can also tell you that well, for this specifically for this demonstration well, I mean it's not for the official documentation well, I mean it's not that user friendly, there are some issues with that. So and but in the meanwhile, we also want to make sure that well, all the demos were realistic. Because we don't really, I don't really want to just to tell people, okay, let's just build a demo, but well, it's not realistic at all. That's not what and you probably for the production environment, you probably need to have another setup. That's probably not really what we want. We actually want to uh, allow people to do the demo in their own laptop and can even put into production in the same way, right? That's why I think yeah we can think about okay how we can directly use the laptop and S3 tables, right? As to build a real lake house, right? That's what we want to do. And definitely, we also want to, yeah, because of for Iceberg, in many cases, we definitely have a lot of data, right? So, so in many cases, you probably not just want to have a single machine, right? You probably want to scale out, right? That's all. That's also one of the things we are thinking about. Well, how to make it easy to scale in and scale out in Iceberg. So, and lastly, we hope that well everyone can just use well we it would be great well if everyone can just use a very simple interface to interact with Iceberg, and for example for Postgres interface. If we could have everything done in Postgres interface, then it'd be great, right? Well, it'd be better, much better than just learning Spark or probably learning how to use Kafka, learning how to use all these kind of very complicated tools, right? So that's what we want to do. And that actually motivates all these kind of things will actually motivate us to introduce what the so-called what the laptop iceberg concept. So for the iceberg, and for the iceberg, sorry, for the laptop iceberg concept, we what do we want to do? What do we have? We only have two things. One is the iceberg catalog. Because for Iceberg is the open table format, right? And you actually probably want to have your own, if you probably want to store everything in your own S3 buckets, right? And you probably have already had used AWS S3 tables, or probably you have already had used the AWS Glue catalog, right? We don't really, if in that case, you probably don't need yet another catalog. So if that's the case, well, let's just use whatever you have, right? So for the laptop Iceberg, we actually allows you to pick up your, I mean, we actually choose to have your own catalog. And in the meanwhile, for Iceberg ingestion, compaction, and query engines, we will show you that, okay, you could essentially use everything in one system that is RisingWave. You don't really need to have different components like ingestion systems for like query engines and then pick the, let's say, EMR, AWS EMR to do the compaction. No, you don't really need to do that. You can just use one single system, right? So yeah, that's what we were used today. And for why Riding Wave, why we use Riding Wave? Because well, you probably were thinking about, okay, oh, what if I use Spark? I mean, definitely you can use Spark to do ingestion, compaction, and query engines. But the problem here is that, well, I mean, you probably need to think about well, how to use the Spark ecosystem, right? And you probably also need to think about, okay, how I can use the, let's say, the install the JVM and install the Docker and install everything. Uh, that's in the Java ecosystem, right? But for RisingWave, it's written in Rust, and it's Postgres compatible, which means that okay, you can just interact with RisingWave using Postgres protocol. For example, here I can just show you so it's a very quick demo. It's a very hold on a sec. Yeah, this is the RisingWave instance, and I can just yeah see okay what do we have, right? So and just use the very standard will create a table, right? Using Postgres for syntax, right? That's very simple to use. And Writing will also work with all different Iceberg catalogs, including Glue, including S3 tables. I mean, S3 table is a package the Iceberg table, right? Manage Iceberg table, and including Lakekeeper, including Polaris, including Unity catalog, right? So and luckily it's all in one. Okay. Yeah, and now let's just ask a cloud about okay how we can do our first demo. So I can just say something like let's think about what we want to do. Assuming that we want to ingest IoT telemetry data into Iceberg using RisingWave. I ask Cloud for how we can directly ingest the IoT telemetry data into Iceberg using RisingWave. And for RisingWave, we actually have two different concepts of two different ways to interact with Iceberg. One is that okay, we actually have a concept called the internal catalog, which means that you can just use Iceberg as the Iceberg table as the very standard rising wave table or the Postgres table, right? And the semantic is like the statement is like okay, to create the Iceberg table, the statement is like okay, just create a table user events and engine equal to Iceberg. So that's where you can directly ingest the data into Iceberg and query data from Iceberg. And in the meanwhile, we also allow people to use another way to interact with Iceberg table. That is called the external Iceberg table. So when to use it? I mean, if you have different destinations, well, let's say you want to sync the data into both Kafka and Iceberg, then potentially I think the external Iceberg is a better way to I mean interact to interact with Iceberg. The reason here that you can definitely in writing wave you can actually create asyncs in different to different destinations like Kafka like Postgres, like Iceberg, right? So yeah, let's first use the internal table concept. Here it says that Cloud told me that okay, we can actually have the architecture overview is that you can actually have the collect the data from IoT devices and use the let's say Kafka MQTT. RisingWave actually does support MQTT. And directly sync the data into Iceberg, right? We actually don't really need to have message queue. Yeah, that's just the build up quick demo. You may just insert data directly into. Okay, what do we do? So here, The first example, well, I didn't really chat, yeah, prepared with this with cloud, but what it showed was that essentially, if I want to ingest the data from IoT devices, and assuming that well, IoT devices will have already been have already stored in Kafka, streaming into Kafka, then here what cloud says is that we can actually create a source in order to connect to Kafka, and then create an internal table called the IoT telemetry table. So in this way, you can directly use this statement called create a sync IoT to Iceberg into. So basically, create yeah sync the IoT stream data into the IoT telemetry data, IoT telemetry table. So that's yeah, that's how we can do that. Well, if we have the Kafka data and we want to sync the Kafka data into Iceberg tables. And then here I told him that okay, no, we actually don't really want to have a message queue because well, Ice RisingWave itself is like it's a streaming system, and we actually offer the buffer. You don't really need to have Kafka, but definitely, yeah, if you think that's where you have already had a self-hosted Kafka, for sure you can do that. But if you don't really want to have Kafka, for sure that's fine because RisingWave itself offers the buffering capability so that you can just directly write the data into Iceberg. And okay, let's see how what cloud is currently working on. Um, okay, it does directly build a demo for me, right? You can see that so it says it has already executed for this statement called physical. Okay, it connects to my local RisingWave instance and say that okay, it actually also created an Iceberg engine connection, right? Okay, wait a sec. Hold a sec. Okay, it also um yeah, it also tries to okay, it has already finished. So it says that well, it actually the architecture is like IoT data syncing into yeah it directly insert data into Iceberg internal Iceberg tables and then sync the data into S3. And this time it doesn't really use S3 tables, but instead it actually uses the glue catalog as well as the S3 S3 and store the data directly in S3 and show me all the queries. Show me all the queries in a demo. Yeah, it's okay. It's not slow at all, right? Yeah, I don't really know why it uses. Oh, actually, yeah, for this part, well, I mean, definitely because well, I actually yesterday I actually asked Cloud to help me prepare a demo with Super-based CDC, so that we can directly ingest the Super-based data into Iceberg. So that's why it actually has the S3 this S3 bucket. But anyways, well, as you can see, if you really want to directly ingest data into Iceberg, then the only thing you need to do is to create a connection, which means that okay, which actually tells RisingWave where your catalog is, right? Where your S3 bucket is, right? Or where yeah this in this statement well, where the glue catalog is, right? Because we say that's what the glue catalog. It actually uses a glue catalog. And then the only thing we need to do is to create an IoT telemetry table. And in order to identify this is Iceberg table, you can actually use this statement called engine equal to Iceberg. And after that, you can just insert data into Iceberg as a just like interacting with the normal Postgres table. And lastly, it also select the data, right? So yeah, and yeah, and lastly, it will also select directly select the data using RisingWave's engine, right? And here, let's just copy paste this statement. and copy paste to here. Okay, you can see that okay, we have already had the data, right? And but what if we just want to now want to use for RisingWave engine, right? Because for Iceberg, the cool thing here is that you can actually use different query engines, whatever query engines you want to use. And let's just ask Cloud, um, can you query the table, query the data using DuckDB? Do it now. Okay, let's just use DuckDB to query the data. I just want to mention here that well, I have not installed a DuckDB and I haven't tried a cloud to install DuckDB. So let's see what do we do. Okay, it actually started DuckDB and okay, it already queried the data, right? Okay, DuckDB has already read the Iceberg data directly from S3. Show me the queries, right? Show me the queries. Don't really just okay, let's just control O plus expand. Okay, forget about it. Show me all the queries. Let's see how Cloud actually use this DuckDB to query Iceberg. Hmm. Yeah, so basically what it does is that so it actually installed this is the DuckDB query. It's not my query. It's not a RisingWave query, but for DuckDB query. For DuckDB, what do you want to do? If you want to use DuckDB to query Iceberg, you need to first install the Iceberg extension and load it, and also and then tell DuckDB where AWS credential is, right? Well, where the AWS bucket is, right? And it does the S3 scan, sorry, Iceberg scan, and directly scan the bucket files. So yeah, uh, how it works, right? So it's very simple. So yeah, in this demo, it shows that well, it actually used the DuckDB to query Iceberg. And if you want to use, let's say, Spark, or probably if you want to use, let's say, ClickHouse to query Iceberg, you can definitely do the same thing. And it's super simple to use. In the meanwhile, as I mentioned, well, I mean, people actually, a lot of people told me that well, they probably use some Postgres instances well, to collect their, let's say, operational data, right? And how we can use Postgres to how we can use RisingWave to ingest a Postgres CDC and sync the data into Iceberg in real time. Because well, I mean, because well, I have already installed a Superbase and granted cloud access to the Superbase instance, we can directly ask cloud to create a demo that ingest the data from Supabase CDC and sync and deliver the data into Iceberg. This time we no longer we no longer use RisingWave's we choose to use RisingWave external Iceberg tables instead of internal Iceberg tables because well in the previous demo I've already showed you how to use RisingWave internal demo. Sorry, internal Iceberg tables. Here I want to show you. Let's use RisingWave's external Iceberg tables this time. Okay, so what it does is that way it actually tries to Um, yeah, create a sync. Well, yeah, this is still my uh my RisingWave instance. But let's just wait for a few seconds. Yeah. So Supabase is for when I connected to Supabase yesterday, I found that it it actually yeah, in order to support CDC, you actually need to enable CDC in your upstream Postgres instances. And essentially, I found that where you can actually do everything automatically using a command line. You actually don't really need to log into Supabase and do the all yeah, if you use Neon. You don't really need to log into your Postgres instances and turn on CDC. You can do everything in command line. So that's the simple part. So here it says as well, it actually tries to create seems as well, Cloud actually tries to create uh, yeah, what is currently working on. Okay, it seems as well, it actually tried to, yeah, it has already successfully written data into S3. And is it successful? I think so. Yeah, it's successful. Never use the word code. Okay. Okay, you can see that, well, okay, it actually also queried the data, has already successfully queried the data from the external iceberg table, right? So it seems as well this demo is very successful. Okay, that's cool. That's really cool. Yeah. Okay, so it says that well, the data flow is like you have the Supabase CDC, right? Where you have a Supabase Postgres instance running. And then what it does is that will it actually show me all the queries. It actually created a Iceberg CDC table and then used it to, because we asked it to use Iceberg RisingWave external Iceberg instance, right? So it essentially, okay, let's see all the queries. Okay, here are all the queries. So the first step is that well, it actually yeah, where is the create a CDC part? Yeah, here. Here it is. Um, no, this is to directly query Iceberg table. So how did you Supabase? It's very exciting to do this kind of live demos because well, it's AI, right? Well, it's not me that does the live demo. So if there's something goes wrong, I can always blame Cloud. But I feel that for Cloud is smarter than me because for the yeah, in many cases, well, I actually have to figure out okay, what kind of queries I want to use. But for Cloud, it seems that well, it actually just automatically uh does all these kind of things. Okay. Um, cool. Super cool. Yeah. So look, well, I asked a cloud, okay, how did you connect to Supabase CDC? It says that well, okay, in Supabase Postgres, well, it actually created a publication called RW publication. Everything is automatic. You don't really need to log into Supabase to do this. Well, I mean, cloud just does this everything for you in the command line. And then it actually verified for me, right? To verify the CDC connection, the publication, the WAR for me, and it also checked the permission. And afterwards, it told me it actually log into RisingWave and create a CDC source. Here you can see that it uses this statement called create a source, Strawberry CDC, and told me okay where the host is, right? So and my password is hidden, but actually you can actually also use RisingWave's the credential stores in order to hide the password. You don't need to explicitly use the password. Okay. And then afterwards, well, it actually create a table to consume the this is the RisingWave table, and it's called well, the test CDC. It directly consume the data from the Supabase CDC. So yeah, this is how simple it is to ingest data from Supabase. Or yeah, you can definitely use whatever Postgres well you want to use. Let's say the AWS RDS or AWS Aurora or Neon or some other Postgres instances. And afterwards, we just verified everything and then sync the data into Iceberg. So yeah, this is how easy it is to use RisingWave to ingest data from Postgres CDC and then deliver data into Iceberg. Okay, we actually have already talked about for the Iceberg ingestion, right? And for the next part, I will probably I'll show you a very interesting result regarding the RisingWave's query engine. So for radio query engine, I mean, I'm talking about the Iceberg query engine. In the past, we actually only have the we just yeah a very simple query engine to query Iceberg, because well, the RisingWave focus was about okay doing the incremental processing, right? And for querying Iceberg, we didn't really had a lot of optimizations for in the past few years. But for over the last around 6 months, is we actually spend a huge amount of efforts into that. And we didn't really choose to implement everything from scratch. Instead, we picked the engine, the data fusion query engine. And why we pick the data fusion engine instead of building our own engine? The reason here is that we find that data fusion engine is first of all super easy to use. Second, well, it's reading in Rust, and RisingWave itself is also reading in Rust. And third, it's highly performant, right? And the thing we did was that well, but well, I mean, definitely and we try to over the last 6 months is we try to embed the data fusion into the RisingWave instance into the RisingWave the code base. And the thing we did was that well, most of the efforts was on how we can connect data fusion to RisingWave's front end, which means front end means the SQL parser, SQL planner, all these kind of things. And after spending a few months is for baking with planning with data fusion, we now have the results. And this is the result we just did for last week on the very small table. It's not a big table, but well, I mean, it's just 100 gigabytes for TBCH benchmark, right? But definitely, if you're interested, you can definitely use a bigger table. But and we compare the data fusion engine with DuckDB as well as the another data query engine. So yeah, we just hide the name. But for data fusion, but DuckDB is definitely a well-known system, right? And well-known system that can embedded system that can create that can query Iceberg. So don't really ask me about okay why we don't really benchmark with let's say something like Trino, Databricks, Snowflake, Lakehouse, whatever, right? Yeah, you can definitely check what the other people's benchmark. They have already done a lot of benchmarks on this topic, but here and I don't really want to get involved into yet another let's say benchmarking war, right? I just want to focus on okay how good data fusion engine is, right? Because well, that's our own focus. So Iceberg, DuckDB was for the DuckDB is definitely also very performant. I think well, it's definitely one of the best engines we have already seen. So the result is actually very good. as you can see, for most of the queries, the lower is better. Okay, lower means that's okay. It consumes much less time. So as you can see, for most of the queries, we can see that for data fusion's performance is very competitive to DuckDB. The only issue we found here that well, for in some cases, well, actually there are some OOMs, out of memory issue, like Q5, Q3, Q5, and yeah, and Q18 and Q21. Yeah, and this was just some small issues with the planning because once you have better planning, you can definitely improve the performance. So we haven't finished working on that, but essentially, as we can see here, Data Fusion's query performance is really good compared to any other, especially here with DuckDB. It's very good with DuckDB. So that's why we choose to embed our data fusion engine as our default for the choose the data fusion engine as our default query engine for the Iceberg for Iceberg tables. And for this feature, it will be released in within two weeks in RisingWave 2.8. And with RisingWave 2.8, you will definitely have a really fascinating Iceberg query engine query performance. So that's why you don't really need to have any other dedicated systems to query Iceberg. But for sure, because of I mean, if you have let's say other systems like if you want to do graph processing, if you want to do, let's say, spatial processing, if you do some, let's say, yeah, I don't know, well, any other, yeah, if you have any, some opinions on their opinion, yeah, use some specialized query engines, definitely, as long as they can integrate with Iceberg, you can, yeah, use them as your query engine. So, yeah, so here I probably won't show you how to use data fusion in this demo because well it's kind of like a straightforward, right? But anyways, yeah. Anyways, to wrap up, for today's demo, I've already showed you how you can use RisingWave's internal query engine as well as the external query engine to query internal Iceberg table as well as the external Iceberg table to interact with Iceberg. So with RisingWave's internal, specifically with RisingWave's internal Iceberg tables, you could just create a Iceberg table in the same way as creating a Postgres table and insert data as well as query data from Iceberg. Note that RisingWave can also automatically compact the data for you, so that you don't really need to have any, let's say, use some specialized compactors such as EMR, right? Apache Spark to do the compaction. RisingWave will do it for you all in one single instance. Okay. And a question? Okay. Well, yeah. Anyways, well, that's basically the first step we have for the so-called laptop iceberg context. Well, sorry, laptop Lakehouse concept, and you can definitely try these things as well in your own laptop or in your own server, and it could be run in production for sure. Because actually, essentially, I know that a lot of our users and customers have already done this. And if you have any questions, well, definitely feel free to reach out to me. And I'm always in the Slack meeting. And you can also directly DM me in LinkedIn or probably Twitter. So yeah, I think that's probably all for today's webinar. Okay. And we will post more demos as well as the tutorials as well as the iceberg related concept in the future yeah in our official account. All right. Um all right, thank you. Yeah, thanks all. Yeah. See you.